Hello and welcome to this webinar. My name is Srinivas Hanabe. I'm a Principal Product Manager at Amazon Web Services in our deep learning team. I'm the business owner for Amazon Elastic Inference. In this presentation, you will hear about how you can lower your deep learning inference costs with Elastic Inference. First, let's start with the problem we are trying to solve. If you are using deep learning for your business, you're doing two things, training and predictions, also known as inference. The costs associated with running applications with deep learning falls into these two main categories. That is training models and making predictions with them, which is also called inference. We constantly are working towards training models faster and cheaper by offering faster processors and better algorithms for various use cases like computer vision, natural language processing, and many more. We are also constantly working on improving GPU utilization to reduce ImageNet training times, but training is typically a small part of your costs for deep learning. Inference is actually a larger part of your deep learning infrastructure expense to support applications running inference 24/7, with estimates of up to 90% of your deep learning costs coming from inference. So to understand better why inference can get expensive, we'll have to look into the differences between training and inference. Now, inference usually runs on fewer inputs and has less requirements for parallelism. Now, the math intensity for inference operations is lower than that of training, which requires a high degree of parallelism for faster computation and higher throughputs, where throughput is defined as the number of operations per second. So inference is less compute and memory intense than training is. Now, another important factor is that you are making predictions to serve a business need. Therefore, predictions are more closely integrated with your application stack as part of your business workflows, unlike training. Inference can also run at the edge on different devices like video cameras or machines in a manufacturing plant or automobiles, to name a few. And they also run in the cloud. Now, while we focus on inference in the cloud in this presentation, be sure to check out SageMaker Neo for inference at the edge. You run inference a lot more frequently than training. That is the other difference between inference and training. So you're using a lot more CPU and GPU clock cycles than inference, depending on the instances that you're using for your inference needs. In summary, while training has more compute needs, it typically runs less frequently. Therefore, inference consumes a lot more compute for your deep learning requirements, which contributes to 90% of the cost. You also will have challenges in right sizing your compute instances for both inference and your business application because they're both tightly coupled. Now, let's look closer at the problem of right sizing. We see a number of inefficiencies in the available infrastructure that makes up over 90% of the inference costs, of the deep learning costs. First, standalone GPU instances are expensive and are typically purpose-built to train models quickly and efficiently. But they are oversized for inference, as inference happens to be a very different kind of workload. Now, while training jobs batch process hundreds of data samples in parallel, most inference happens on a single input in real time that consumes only a small amount of GPU compute. Now, even at peak load, we very rarely see full utilization of a GPU's compute capacity. Now, this is wasteful and it is expensive. Second, different models need different amounts of GPU, CPU, and memory requirements or memory resources. Selecting a GPU instance type that is big enough to satisfy the requirements of the most demanding resource often results in underutilization of the other resources, and that results in high cost. To lower costs, we'll have to solve both these problems. Now, when you look at what various inference workloads can drive out of GPUs, you'll see that the maximum throughput varies significantly based on batch size. For smaller batch sizes, which are the large majority of online inference use cases, you use less than 10% of the GPU capacity. For this inception model as an example, at a batch size of 64, you are able to process around 1,000 images per second out of the GPU. Uh, and this is compared to a maximum of say 100 images per second at a batch size of 1. So for the majority of online inference use cases, up to 90% of your infrastructure fleet can remain underutilized, which is a significant waste. Note that we are using P3.2XL instances to illustrate this point here. Now, our customers deploy inference in two modes. You can run inference on separate fleets of GPU or CPU instances, or co-locate the application stack along with the model inference. There are pluses and minuses of using both these approaches. If you are running inference on dedicated instances, you have the advantage of being able to right size these instances for pre-processing, inference, and post-processing. You can choose the right set of instances to lower your costs. On the flip side, it does require some operational heavy lifting to manage these fleets. We see our customers use this deployment when they want to serve requests for multiple models with identical application logic. Now, they may also have a specific team that is responsible for managing inference and might want to separate these responsibilities between the inference team and the application teams. You can also co-locate the application stack with model inference on the same instances. Now, this will reduce your operational load. However, on the flip side, you can have mismatches between the host and the accelerator resources that can lead to over provisioning of the resources. Now, a quick example is that one of our customers who does computer vision modeling was using P2 instances for their inference fleet, and were using Z instances because they wanted memory intense instances for their application stack. Now, for this customer, there were higher operational costs in managing two separate fleets. But to reduce the operational cost, they wanted to combine these two fleets into a single fleet that used memory optimized instances. So what is the solution for these kinds of use cases? So what if you could keep your application on your familiar CPU instance and attach just the right amount of hardware acceleration for inference? Right? And that is where Amazon Elastic Inference comes in. So Amazon Elastic Inference, or Amazon EI, helps you lower the cost of running deep learning applications by up to 75% by giving you the right amount of GPU powered acceleration that is right sized for inference applications. EI helps you size the CPU, the memory, and the GPU acceleration for your application independently. So for your computer vision or natural language processing or other applications where you need smaller amounts of x86 CPU and memory compared to GPU acceleration, you can now choose a small CPU instance and attach an accelerator from a range of sizes that provides you the latency that your application needs while helping you fully utilize your capacity and lower your costs. You can attach EI accelerators to EC2 instances, ECS tasks, and SageMaker instances to apply acceleration flexibly without additional infrastructure management. Right? So when you use EI with SageMaker, you lower costs and also have a fully managed experience. So note that with EI, you can save costs on both deployment models that we discussed earlier, whether you're using dedicated instances for inference or whether you're co-locating the application stack with inference. Now, the EI accelerators are available today in multiple sizes, each with amounts of single precision FP32, mixed precision FP16, compute capacity, right, and an amount of accelerator memory. You can use as low as 2 GB of accelerator memory to as high as 8 GB of accelerator memory. Note that you can compute the requirements for your accelerator memory as the sum of your model and the size of your input tensors. So these are available at prices that are significantly cheaper than GPU instances. And the smallest accelerator costs just 12 cents an hour in US regions. Elastic Inference is available in Northern Virginia, Ohio, and Oregon regions in the US, Dublin in EU, Tokyo and Seoul in the Asia Pacific regions. Note that we have got two EIA families, EIA1 and EIA2. Our latest family of accelerators is EIA2 with twice the GPU memory of EIA1 at a lower price per hour than EIA1. Moving forward, we will extend EIA2 to other regions as well. Let's talk about the types of frameworks that we support. Now, EI supports TensorFlow, Apache MXNet, and Onyx models. The service provides EI-enabled TensorFlow serving, TensorFlow predictor, and Apache MXNet software packages that let you deploy models on these framework types with zero code changes. So again, there is no code change that's required as long as you're using TensorFlow or Apache MXNet. You do have to download the Amazon EI versions of TensorFlow as well as MXNet to use. And once you do that, you do not have to make any code changes to use Elastic Inference. So the Elastic Inference experience is very similar to using a GPU within your instances. The EI-enabled packages, they automatically discover the presence of an accelerator and they efficiently offload operations within your model to run on the attached accelerator. So you can find these packages within our deep learning armies for your EC2 instances and our deep learning containers. You can use EI accelerators within SageMaker notebooks or hosting. And you can also download the appropriate pip packages via S3 to install on your instances. So how does Elastic Inference scale capacity with both EC2 and ECS in a cost-optimized way? So you can specify an Elastic Inference attachment on an EC2 instance or ECS task. EC2 launch templates will let you configure EI accelerators for your instance, so you can scale instances along with their attached accelerators as a single unit with EC2 auto-scaling. So you can use auto-scaling groups. And by using EI within these auto-scaling groups, you can control your desired capacity for instances and accelerators for your application's varying needs. SageMaker fully manages this experience for you. So if you're using Amazon SageMaker, you can prototype deployments with notebooks, SageMaker notebooks, and you can attach Elastic Inference to these notebook instances. You can then deploy these models on SageMaker endpoints with cost-effective EI acceleration. So this is on SageMaker hosting, and you can then deploy these Elastic Inference accelerators with the instances that you can choose within SageMaker hosting, and SageMaker hosting will automatically manage the instance fleet for you, depending on your usage. So with that, let us delve into the EI experience and take a look at the interface for SageMaker and EC2. To begin with, all of this is documented and it's on our documentation but we have a link for setting up Amazon EC2 with Elastic Inference and the different steps required to go through it. All of these steps are automated, by the way, and we have a blog that walks you through how these steps are automated. But I would like to show you the different steps so you understand what the different components are for Elastic Inference. There is a security group setting. There's a private link endpoint that needs to be set up, an instance role with an Elastic Inference policy, and these three things are things that you do once, and then from that point on, you can just launch instances with Elastic Inference. Note that you can launch instances with launch templates. Your instances can be part of an auto-scaling group. Elastic Inference can be part of a auto-scaling group as well. So when you launch new instances, you can automatically, they come up with Elastic Inference. So with that, let's start through these different steps. This is your console. Let's start with the VPC. I'm right now in the US West, Oregon region. I am going to go into my VPC here. And within the VPC, I'm going to set up a subnet. You can always create a subnet and pick an availability zone. So you'll have to pick an availability zone where your endpoint is configured. We'll go through that. For now, I'm going to pick US West 2A. So since this is something that I've already done, I'm going to skip this step. Okay, and use this subnet that I've already created. The rest of those settings are pretty much what you would usually do. I've set up an internet gateway and I've set up a route table so that I can access my instances through SSH. Now, the first thing that you would want to do is configure your security groups. So there's one security group that I've created, and there are a couple of things that you have to do on your security group. The first one is to enable SSH port 22 on the inbound, as well as HTTPS port 443 on the inbound. And then for outbound, I've just allowed all traffic. But at the very minimum, you have to have HTTPS 443 allowed on the outbound. So once you've set up the security group, that's the first step. The next step that you would do is set up your private link endpoint. Click on the Endpoints tab. That's going to bring up the private link endpoint for you. Now you can create an endpoint, and it is and select the Elastic Inference service. So you have AWS services, and within this, you just scroll down for Elastic Inference. So this is Elastic Inference within US West 2. You associate that with your VPC. You're creating the endpoint in your VPC. And then if you select the subnet that you just created, that's an availability zone 2A. You can enable DNS for this endpoint. And then make sure that you're selecting the security group that you just created. Now, I've got all of these things already set up. And so I'm just going to use the endpoint that I've already created, which is this endpoint. And so that completes the second point, so fairly easy. The instance role for this, you just go to IAM, and you need to create an instance role with this policy that allows access to Elastic Inference for these different functions of list, get, describes on EC2. Now again, I have created that role right now. So you can hit the create role to create it. But I have created a role for just that called EI role that has the appropriate policies that's required. Okay, so once you have the IAM, then you can just go to your EC2 and launch an instance. So I don't have any running instances right now, so I'm going to hit the launch instance button. Now within EC2, for your instance, you can select deep learning AMI. The deep learning AMI comes with MXNet, TensorFlow, PyTorch, Keras, Trainers, all of these different packages. And so you don't have to download these packages on your own. Now, if you do want to download the packages on your own, you can always select your own army or even a base instance which has the base packages with the NVIDIA CUDA kernels, and you can build software on top of it. And again, our documentation has steps to do that. Right now, I'm going to select the deep learning army, and I'll select an M5 extra large instance. You could select any instance. Configure instance details. This gives you, so I'm going to launch one instance on the VPC that I just created and the subnet that I just created. I'm going to use an external IP address. I'm going to say enable there so I can access it through SSH. I'm going to specify the IAM role that I just created. And I'm going to add Elastic Inference now. I'll add EIA2 dot say medium. And that's review and launch. And right before launching, the one other step you have to do is to use the appropriate security group. So I'll select an existing group and the one that I just created, which allows me access to SSH and HTTPS. And that's it. Review and launch the instance. Now all of these steps are specified here. Again, you can choose the appropriate accelerator size. I've chosen EIA2.medium, and that has 2 GB of accelerator memory. So that's the instance we just created. I'm just going to use a shortcut to connect to it and SSH into it. Get into the right directory. And that brought me into the deep learning army. Now, you can look at an example over here with TensorFlow, and we're going to use the TensorFlow example, and we're going to do it with a predictor API and follow this example for using Elastic Inference. The first thing you do is a source activate. So this helps you set up with the right package. Note that this is again a deep learning AMI, and so it's set up with all the different packages, and you just have to activate the package that you'd want to use. That includes the framework, the version of Python, and the version of CUDA that you would want to use. So right now we're going to use TensorFlow with Elastic Inference with Python 3, and so that's the source active. So that's how we're going to activate the package. So you run that. Right, so that's done. And now what we're going to do is download a model that we've saved from our repository. And we'll unzip it. And then we'll download a picture of 3 dogs. This is an SSD ResNet model. So we're going to do an object detection over here. And the objective is to detect the dogs in the picture. So the picture that I'm using is this picture. So that's the JPG, the three dogs, and it's supposed to recognize, it's an object detection inference model. What we're now going to do is we're going to use predictor, and so we already have the code for it. So we're just going to cut and paste this code. I'm just going to literally put this code in here and save it as SSD. And then I'm going to run inference. I'm going to run inference with the image, the JPG image that I just showed you. And so what it's going to use is in the back end, it's going to use Elastic Inference. Now, notice that we have a Amazon EI TensorFlow package, as I mentioned before. So this is an Amazon version of TensorFlow that is specific to EI. We manage and maintain this code to the top of the version for TensorFlow. So let's run inference on this, and it is as simple as that. And while it's running in the back end, so this tutorial that I just followed is something that's good to follow through for your own inference needs, and you can attach different Elastic Inference Accelerator sizes to different instances, and you can run inference on these models. Now, in your, again, real-world models, the ones that you're using in production or in your proof of concepts, you should try out different combinations of Elastic Inference Accelerators and instances that can give you the right level of performance that you desire. And that would be one of the best ways to actually go about choosing the right instance in the model that is suited for you. Now, all of these steps that I'm showing here are, at least the setup for EI is automated within the script that we just wrote. On the training itself for the model, for your model and your input tensors, you can automate all of those steps within SageMaker. So SageMaker hosting automates most of these steps for you. So you can train a model in SageMaker and within the same workflows also run inference on SageMaker hosting endpoints. I was just building a library over here. The documentation that we have also lists the various examples that you can use within these documentations. So this is, you can also use not just predictor, but you can use serving as well. And there are different steps for TensorFlow serving too that you can follow. So as you can see over here, you just see that EIA2 medium is being used, and that's the accelerator that we attached to the instance. And it's running an SSD ResNet model on EI predictor. And there's the result. So it detected 3 dogs and in this picture. So it's as simple as that. So with Elastic Inference, again, what I did was I used an M5.large and with an Elastic Inference accelerator, medium accelerator, and the inference, finished. The actual inference call, which I've measured before, was about 9 milliseconds. So it's not the whole thing. So most of this time that was spent was on the packages, but the actual inference call itself was 9 milliseconds. So, and then of course, you can rinse and repeat. So if you look at the code that was used to run this, so most of it was really around setting it up, and the actual inference
was right at the end, which took a very small period of time. So that is your EC2 experience, and again, most of this is automated. Now, go back and look at the SageMaker experience. I'm just going to show you uh, one part of it, which is to be able to set up SageMaker notebooks. You can also set up hosting. So the first thing you do is you go over to SageMaker. This is the SageMaker console. Let's look at notebook instances. So the experience is very identical. So the way you do it is you create a notebook instance. You would call it AI test. You can select any notebook instance type that's available. Let's just use a T2.medium, and then you can use an Elastic Inference Accelerator, and you have the same options that I just showed you. So for instance, you could use EIA2 medium, and then you can use an IAM role within SageMaker that gives you access. So that could be SageMaker access. I'm going to use the SageMaker access role here and create a notebook instance. Um, and there the notebook instance is being created. So from this point on, you can use your notebook instance. There are a number of different examples we have within example notebooks that you can use with EI for your testing. We're just going to wait a second for this. So the SageMaker experience is much more automated in the sense that you can create notebooks, you can go through training, you can attach an EI to notebook instances and test your inference as well before you actually deploy it. When you deploy it in production, you would then use inference with your endpoint configurations that include EI. So this is the SageMaker hosting. Um, So let's go back. So this is how you would set up an EI with the notebook instance. Uh, so hopefully that gave you a good sense for how to attach EI to an instance. So once you attach an Elastic Inference to an instance, it stays attached to the instance through the life of that instance. So once the instance goes down, when you terminate the instance, you can EI will be terminated as well. The attachment will be terminated, and you will be no longer billed for that elastic inference.
So now that you figured out, now that we saw how to attach Amazon Elastic Inference accelerators to EC2 as well as SageMaker, let's look at how you can use your frameworks to seamlessly make inference calls. Now, as you can see, there is no change to your code when you use Elastic Inference. You can use the TensorFlow code for Amazon EI to make inference calls. So for further information, you can refer to the Elastic Inference documentation. So if you look at the code over here, it's Amazon EI TensorFlow serving. So within MXNet, similarly, there is no change to your code when you use Apache MXNet either. You can use the MXNet code for Amazon EI to make Elastic Inference calls. Again, for further information, please refer to the Elastic Inference documentation. So how do you choose among different accelerators? Now, demands on CPU, compute resources, or CPU memory or GPU-based acceleration and GPU memory can vary significantly between different types of deep learning models. The latency and throughput requirements of the application also determine the amount of compute instance and the Amazon EI acceleration that you need. So consider the following when you choose an instance and accelerator type combination for your model. Before you evaluate the right combination of resources for your model or application, you should determine the target latency and throughput needs for your overall application stack, as well as any constraints you may have. Now, for example, if your application needs to respond within 200 milliseconds and data retrieval, including any authentication and pre-processing takes 100 milliseconds, you have a 100 millisecond window to work with for the inference request. Using this analysis, you can determine the lowest cost infrastructure combination that meets these targets. Now start with a reasonably small combination of resources. For example, you can start with a C5.extra large instance type along with an EIA2 medium accelerator type, which has a 1 teraflop of FP32 performance and 2 GB of GPU memory. You can then size up on the instance or accelerator type depending on your latency targets. Now, some use cases may require memory optimized instances or compute optimized instances, um, R, M, or C. So that really depends on the application type that you're running. Now, since Amazon Elastic Inference Accelerators are attached over the network, your input or output data transfer between the instance and the accelerator adds to the inferencing latency. So using a larger size for either or both the instance and the accelerator may reduce your data transfer time and therefore reduce your overall inferencing latency. Now, if you load multiple models to your accelerator or the same model from multiple application processes on the instance, you may need a larger accelerator size for both the compute and the memory needs on the accelerator. You can convert your model to mixed precision, which utilizes the higher FP16 teraflops of EI for any given size. And this can lower your latency and improve your performance. So to summarize, know your GPU memory requirement, your target latency, and your application requirements for your client instances. You can then do a proof of concept to see if your latency requirements are met. If not, you can size up the accelerator, the instance, or both. Now here's a comparison of the cost of using a C5 large instance with Elastic Inference to other GPUs, including a G4, a P2, and P3 instances. Now you can save significantly on a dollar per hour basis by using Elastic Inference accelerators. So note that you can use this metric when you have lower inference volumes of up to a few inference requests per second, or it could be hundreds of inference requests per second. So but you still need to run these instances, say 24/7 or for long periods of time. Now, for example, you may have a real-time application that is serving your web requests. Now, in this case, EI can help you save more than 60% of your costs. So again, in this chart, uh, the left three are C5 large instances with EIA2 medium, large, and extra large. And as you can see, those are much lower than the G4, P2, and P3 instances that we have illustrated on the right side of the bar chart. So what about performance? If you look at the latency per inference call, the above shows you C5 large instances and EIAs, Elastic Inference Accelerators, that are compared to GPU instances for some common models. We've used ResNet 152, Inception, and MobileNet as examples over here. The left three on the bar chart are EIA2 medium, EIA2 large, and EIA2 extra large with C5 large instances. So notice that your latencies reduce as you go to larger EI models, Elastic Inference models, Elastic Inference types. which means it reduces as you go from EIA to medium to EIA to dot extra large. You'll also see that Elastic Inference has additional latency over some of the GPU instances because it is attached over the network and because it uses a slice of the GPU. Right? So you can get your desired throughput and latency targets on Elastic Inference at a lower cost depending on your inference volume. The model used uh, also matters, and the CPU instances that you're using matters to the latency as well. So what we recommend is that you do a proof of concept to choose the best combination of instance and accelerator that meets your needs, as we described earlier in our description of how to right size your instances as well as your Elastic Inference accelerators. Um, while there are a number of other details, I wanted to highlight one case where you cannot use Elastic Inference if you're, and that is when you're programming on CUDA or CUDNN libraries. So that functionality is not available today in Elastic Inference accelerators. So if your applications are using native CUDA or CUDNN libraries and are not going through frameworks like TensorFlow or MXNet or Onyx, then we would recommend using a GPU instance for your acceleration. Right now, EI is available via frameworks, namely TensorFlow, MXNet, and Onyx, and we will plan to expand framework coverage over time. Now, another common question that appears is whether we can detach Elastic Inference accelerators from instances. The answer to that is no. Once you create an instance and you attach an Elastic Inference accelerator to it, or you create an ECS task during the task definition process, you can specify an Elastic Inference accelerator. And once you do that, the accelerator will be attached to the instance for the life of that instance until it is terminated. Another common question is about private link charges, whether you will incur separate charges for VPC endpoints. The answer is no. You will not incur charges for VPC endpoints on Amazon Elastic Inference service as long as you have at least one instance configured within the accelerator. And it needs to run in an availability zone where the VPC endpoint is provisioned.
In summary, Amazon EI lowers your inference costs by up to 75% by attaching EI accelerators to any EC2 instance, ECS task, or SageMaker instance to right size for your application needs. You don't have to make any code changes to use EI since the interface is identical to that of a CPU. EI supports TensorFlow, MXNet, and Onyx with support for other frameworks coming soon. Our customers are using Amazon EI today for computer vision, NLP, OCR, and many other use cases for various purposes, including image analysis for, say, security, ballistic identification, post-stage analytics, capturing writing on paper, social media image recommendations, and several other use cases. They are using EC2, SageMaker, or ECS platforms and have reported cost savings of anywhere between 30% to up to even a 10x improvements. So finally, the best way for you to experience EI is by trying it out and doing a proof of concept to see how easy it is to really use it. And visit the link that I just ran through for trying a live example. That's the last link in this slide. So you can try a live sample and see and walk through the experience of using Elastic Inference yourself. And finally, thank you very much and have a great time trying Elastic Inference.